Hello! In this video, we'll talk about some examples involving Doppler's effect. So we'll start with May June 17, paper 1-2, question 25. It's an objective question. You can pause the video to go and find the question. It's page 15 on my notes. So let's read the question together. An ambulance travels along a straight road at a speed of 30 meters per second. Its siren emits a sound of frequency 2000 Hz. The speed of sound in air is 340. The ambulance passes a man standing on the side of the road. What is the frequency heard by the man as the ambulance moves towards him and moves away from him? So I'm just going to write the general equation for Doppler's effect first at the side for reference. Fo over Fs is equal to the relative ratios of the speeds times the frequency. Okay, so right now we're going to substitute. So I'm just going to bring up and multiply lah, which is easier. So speed of sound is 340, speed of source is 30. Okay, and then multiply that by 2000, which is the source frequency. Okay, we're going to repeat again. Right now, the bottom part would be negative because they are moving away from each other. Okay, so this part here minus 30, so this is 2000. And pressing calculator a bit. So while we wait for my friend to press a calculator and write the answer, generally, right, the V plus or V minus Vs is relative speed. Okay, so whether the frequency increase or decrease depends on whether they are moving together, increase, moving away, then decrease. So if they are moving together, that means it moves towards him, that will be an increase in frequency because the wave are squished together. So 2190 would be towards, and 1840 would naturally be away. Then your answer would just be D. It's the closest one. Okay, so we're going to move on to another question. This is October, November 16, paper 2-1. You can find this question in page 24 in your notes. I've written down the definition of frequency here, but I want to highlight some important errors that you can have, especially if you are not a type that looks at mark schema, lose marks here, a bit sad lah. So let's read my answer. Number of oscillations per unit time of a wave particle, it is 2 marks. So I will highlight where the mark is in a separate color, okay? So number of oscillations per unit time is 1 mark. I've marked your first task. Most of you got right this, but a lot of you didn't mention the wave particle, which is the second mark. Alternatively, you can also say is number of wavelengths. Remember the derivation for today's lecture, number of wavelengths per unit time passing a fixed point. So the observer could also be seen as a fixed point. All right. So in part B, so 1 mark each. The reason why we say passes a fixed point is because it's a progressive wave. Okay, in part B, a cathode ray, a CRO is used, and then you get this tracing. You are asked to show that the frequency is 1006 Hertz. So the first thing you should do is to count the wavelength. Now, you all always got problem when the wave is neither here nor there in your scale. Okay, so what we're going to do, right? I mean, now I'm using OneNote, I can zoom in, but in the actual exam, you should just try your best to be able to find where the wave starts at the corner of the boxes. Okay, so I'm going to zoom in soon, hopefully. Okay, and you will see that there are certain parts where the graph cut the corner, and those are the parts that I will take because I know for certain what value that is. So I'm going to start with the peak on the left hand side as I mark in blue right now, and I will find another point where the graph passes through a corner, okay, which I can see. I'll take that one because I know how to count cycles by quarters, so I'll take that one. So if you count right, this is actually 1 3/4 cycle. Okay, so I'll mark down this is 1 cycle, and then until this point would be 1.75 or 1 3/4. 1 3/4. Okay, so if you're a bit struggling, I will now label the 1 3/4 for you. So you can see from here to here, the wave has traveled 360 degrees. Okay, if you are more trigo inclined, this is 1 cycle. And from there, the second portion, that will be a quarter of a cycle, 270 degrees. So you have 1.75 T. But the question here is how many cm is this 1.75 T? So 5 boxes is 1 cm. So I'm going to use a different color to annotate this part. Okay, so in front here, you're going to start from here and we will measure all the way to the end. And that large one is 2 cm, the small one on the side is 1 cm, and this is 7 boxes, so 1.4 cm. In total, it will be 4.4 cm, which is equivalent to 1.75 cycle. Okay? Right, so I'm going to zoom out now. And from here, you can now calculate the value of t using the time base. So I will write down the working for you. 1.75 T is 4.4 cm, but 1 cm is 250 microseconds. So I'm going to multiply -6 for micro. Okay, and move things around and take out my calculator. I will be able to get a value of T. This kind of intermediate calculation is important, especially when you're proving. Okay, so whenever you do questions like this, it's good to refer to the mark scheme to see where the marks is, because I think this 6.28 times 10 to the power of -4 got 1 mark lah. Anyway, F is 1 over T. If you invert this, I think you will arrive at 1590 Hertz, okay, which is close enough to 1600 Hertz lah when you round it to 2SF. Okay, so now this 1600 Hertz loudspeaker emits the sound in all directions. Okay, a person attaches the loudspeaker to a string and swing the loudspeaker at constant speed above his head. Very free, yeah? So he hears a maximum frequency of 1640. So maximum must be compressed towards the observer. Okay, so I'm going to use the ratio again. FO is equal to V over V. So now I will take minus as my denominator because it's smaller. Smaller means the denominator would be minus law. Okay. Sorry, not smaller, larger. If larger, the denominator should be minus. Okay, so 16400 or 1600. Okay, because I bring over the FS. All right, and I'll get 330 over 330 minus the source speed. Okay, so I'll move things around. So here is where it's important to understand. Whenever we look at whether the frequency increase or decrease, we are going to see the relative motion. Okay, and looking at the relative motion, if they're coming closer together, the wave are squished together, frequency increase. For frequency to increase, if you look at that ratio, the bottom part or the denominator must be minus. All right, so if you solve the equation, you will get 8.25. We will move on now. So we're going to describe qualitatively how the frequency changes actually as the loudspeaker turn horizontally like this. And if they say qualitatively, we will use words law, okay? All right, so of course, you will hear high pitch, low pitch, high pitch, low pitch. So you could say that, oh, there's a repeated high and low pitch as the loudspeaker travel towards and away, towards and away, or approaches and leaves the observer or the person. And it's a periodic thing lah, because it's moving in a circle this way. Okay, so high pitch, low pitch, higher pitch, lower pitch. But when you say high and low like this, it's always a little bit problematic one, because high how high, low how low. So I think it is better if you have like a better sense of writing better explanations just for you to be safe. High and low is very risky. It's better if you change the high and low to higher and lower to indicate that there is a change from 1600 Hertz. If I hold the loudspeaker here, you will hear 1600. Higher than 1600, lower than 1600, higher, lower. So I need the ER in your answer. Okay, when I mark, I'm very particular about explanation lah. Okay, just to train you. So higher and lower pitch as compared to 1600 or the source frequency. Okay, so I will minus 1 mark 1 if I see this. Okay, just is I will always talk about examples this way. Or if you're like, wow, you think so much, then you write a simpler explanation. Okay, you can say that the loudspeaker, when it's moving away from the person, away, so you stretch out the wave, this causes the frequency to drop, or a fall in frequency, or a decrease in frequency. But you also must say two side law, move away, frequency drop, move towards, frequency rise or frequency increase. Okay, so this causes a rise in frequency. Okay, so that's the two examples we have for today. Please try task 1.3, okay, and 1.3, sorry, task 1.2. And yeah, I think if you can do that, you are fine. Did I write 3 or 2? Great, I write 2. All right, I will see you